So finally, students, let us find out the relationship of quality factor with the relaxation time as well as log decrement. Now, since we know that A is equal to A0 e to the power minus kt and Q is equal to omega prime by 2k, therefore, we can write A equal to A0 e to the power minus omega prime t by 2q. We can write this, okay? So, you see, therefore, alright, so if we consider the energy, alright, so amplitude in terms of quality factor, if we consider the energy, what is the energy? E equal to? E is equal to half of m omega prime square A0 square e to the power minus 2kt. Okay, so this is equal to half of m omega prime square A0 square e to the power minus 2 omega prime t by 2q, isn't it? So this actually will be equal to, this will be equal to what? This will be equal to E0. If you take this whole thing as E0, this will be equal to E0 e to the power minus omega prime t by q. Okay, alright. So that is the relationship between quality factor and energy. Suppose you try to find out the relationship with logarithmic decrement. What do you get? With logarithmic decrement, well, what do you get? You see, lambda is equal to kt, which is equal to k into 2 pi by omega prime, isn't it? It is equal to k into 2 pi by omega prime. Alright, so that is equal to, what is it equal to? In terms of q, this will be, because omega prime by 2k is q, so this is equal to pi by q. How do you correlate relaxation time with q? Relaxation time with q. How do you correlate? Well, the relaxation time TR is equal to 1 by k, which is equal to 2q by omega prime. Okay, alright. So this is how you correlate the relaxation time with q. Let us take a problem. For example, in an LCR circuit, okay, suppose say L is equal to 1 millihenry, okay, C is equal to 10 microfarad, R is equal to 0.4 ohm. You have to calculate Q. Calculate Q. Okay. And you have to deduce the frequency. Okay. So you have to first calculate Q. What will you do? What formula will you use over here? See, what is your formula for Q? The formula for Q is, what is your formula for Q? So the formula for Q is what? it is equal to, these are very important, you remember the formulas. If not the deductions, at least the formulas for your problems, okay? This, and for an LCR circuit, you have seen already that omega prime is equal to square root of 1 by LC minus R square by 4L square. So if you make the substitution for L, C and R and the corresponding substitution for omega, if you put the values of L, C and R, what are you getting for omega prime? Please calculate. This is your assignment and this you have to submit, okay, at the end of the class. Alright, now you have to deduce the frequency and quality factor similarly for an LCR circuit. So having an LCR circuit, say now this is problem number 2. Again an LCR circuit where you have L equal to 2 millihenry, okay, C equal to 5 microfarad and R equal to 0.2 ohm. So you have to now deduce the frequency and quality factor. So you have to deduce omega prime and Q. You have to find. So you have to now use the formulas to find your Q and omega prime. Okay, same formulas to find Q and omega prime. Okay, now, well, suppose you are asked to show, you can take this problem for quality factor, okay, suppose you are asked to show, all right, suppose you are asked to show the following example, the fractional change in the natural frequency of a damped simple harmonic oscillator. You have to show, so this is problem number 3, okay, show what? That the fractional change in the natural frequency of a damped simple harmonic oscillator. Show that the fractional change in the natural frequency of damped harmonic oscillator is 1 by 8Q square, where Q is the quality factor. How will you show it? If omega 0, how will you show this? Q is the quality factor. Alright, how will you show this? Now you see, well, if omega 0 is the natural frequency, you know it is the natural frequency of oscillation, omega 0. Omega 0 is the natural frequency of oscillation of an undamped oscillator, isn't it? And omega prime is the frequency of oscillation of a damped oscillator. Frequency for damped oscillator. For damped oscillator. Frequency for damped oscillator. Okay. Then omega prime is equal to square root of omega 0 square minus k square. What is k? K is the damping constant. Also, if you correlate k to R, the damping coefficient, it is equal to R by twice M, because 2K is equal to R by M. R is the, what is R? R is your damping constant, isn't it? It is the damping constant. So what can you write about omega prime? Therefore, using this, you can write your omega prime as equal to what? Omega 0 square minus R square by 4m square whole to the power of half. Now R is small, so this you can also further write as equal to, you can also take out omega 0 from this expression by making a small trigonometrical calculations. You can bring out omega 0. Okay, if you bring out omega 0, what you get over here is 1 minus R square by 4m square omega 0 square whole to the power of half. You can say this, isn't it? Now see, R is small. It's a, so the whole thing with mass and frequency is a very, very small quantity. So you can apply your binomial expansion over here. All right, what can you, so since R is small, so this quantity is very small, so expanding binomially. Okay, so expanding binomially, what do we get if we expand it binomially? So expanding binomially, we get omega prime equal to omega 0. Please watch. Maybe if I go wrong, then you will have to later, or maybe then I'll have to repeat because no one is here now to point out. Minus half R square by 4m square omega 0 square plus higher order terms are even smaller, isn't it? Higher order terms are even smaller, so they are neglected. So what you get over here is omega prime by omega 0. It is equal to 1 minus 1 by 8 R square m square omega 0 square. Okay, so what do you get from, if you do further calculation, you can show that omega 0 minus omega prime by omega 0, what will that be equal to? Let us see. Okay, omega 0 minus omega prime by omega 0. All right, what will that be equal to? Omega 0 minus omega prime by omega 0. That will be equal to 1 by 8 R square m square omega 0 square. But what is Q equal to? Q is equal to m omega 0 by R. So, well, omega 0 minus omega prime by omega 0 is equal to 1 by 8 Q square. Now, this is a bit tough proof, so I am doing it, I have done it. But the point is, you might get it for your exams, you might not. But it's better to know how to tackle problems of this type.